Hi guys, today I'm going to talk about how to impute missing values in machine learning. So no machine learning algorithms or no machine learning model works with missing data. That means if particular cell or data is not filled, then the algorithm will be generating an error. So in that case, so you have to either drop the missing rows or missing data or missing columns, or you can impute. Imputation means filling the values. So here I'm going to take a sample data set and going to demonstrate what are the different ways of doing the imputation. So in order to demonstrate this, at first I'm importing pandas, and I have sample data in my file emp.csv, which I kept in my data folder, and displaying the data frame. So you can see this is the data, and in name no column is missing, whereas in A's you can see NaN. NaN stands for not a number, which indicates missing value. Again here you have missing value. In position also missing value, here also missing value, missing value. So these columns are having missing values. So if you directly go for applying any machine learning algorithm on this data set, so you'll be getting errors. So that's why we have to do the imputation. So how to check the missing values? In that case you can use the function isNA on your data frame, dot sum, means it will sum up all the missing values in each column. Even you can use the boolean function is null. So you see in name we don't have any missing values. In A's you have 2 missing values, in position 1, in experience 1, in salary 1. So we have come to know what are the missing values, the number of missing values in columns. Then what are the methods exist? So we can adapt these two techniques. You can drop rows with missing data, or you can replace a missing value with some data. So let's see the first way. The first way is dropping rows with missing data, and here you have these options. You can drop all the rows which are having any missing values. So in the drawback of this removing the missing value is you may lose the data, right? As per the studies, if more than 50% data is missing, then you can drop a particular column, or else you can go for imputation. So that is the first option. Then drop only if the entire row has missing values, or drop only if a row has more than 2 missing values, or drop NaN in a specific column. So these are the 4 options. So let's apply these 4 approaches. So the first one is dropping all rows which are having missing values. So I'm loading the data set again and creating data frame df1, and checking the df1 dot drop na, means it will drop all the rows which are having missing values. So this is the method drop na. Now you can see row number 2, 3 and 7 have been removed, and in this data there is no missing value. Next, second option is drop only if the entire row has NaN values. I think we don't have such a scenario over here, so not a complete row has missing values, but let's see how to apply that. So loading the data set again, and then df2 dot drop na, how is equals to all. It means if the entire row has missing values, then that particular row will be dropped. So no row has been dropped here. Then case 3 is drop only if a row has more than 2 missing values. So again creating a fresh data frame, and then using the drop na method, the parameter over here is threshold. Threshold is equals to 3. So row number 2 has been dropped. In row number 2, how many missing values are there? Let's check it out. In row number 2, three are there. 1, 2, 3. So that's why the condition is true and the row number 2 has been dropped. Then case 4, drop NA in a specific column. So in experience we have missing values. I am creating a data frame again. Then df4 dot drop NA subset. So here you can specify a subset of columns, set of columns. So I'm just specifying a single column, and if you have missing values in experience, then that particular row will be dropped. So row number 2 is dropped. Yep. And you can also specify multiple columns here, experience and age. So these are the numeric columns, and you are dropping the missing values. So in experience, no missing values. In age also, no missing values. So what are the rows which are dropped here? So row number 2, then 3 also dropped. Yeah, 2 and 3 are dropped. So these are the ways of dropping missing values from the data. Then how to replace missing values with the data. So these are the 4 conditions, 4 ways here. You can replace the missing values with mean, or you can replace a missing value with mode and median. So mean, median, mode, or else you can also replace the missing values with some constant value. So these are the parameters which are used to the imputer. So we are going to use the imputer class from scikit-learn, and by using the function you can specify the parameters like missing values. So how the missing values are identified. So with NaN, then what is your strategy, either mean, median or mode. What is the axis? It could be row or column. Axis 0 means row, axis 1 means column. Verbose means displaying the verbosity of the imputer. The default value for verbose is 0. Then copy. Do you want to make a copy of the data or not? So these are the 4 options, and let's see how to use them as parameters within the imputer method. So simple imputer. So the first approach is imputing with mean. Here you must know the point. So if your data is numeric, then you have 2 options. Either you can replace with mean or you can replace with median. Now the question is, when you replace with mean and when you replace with median. So if your data is no standard, that means if there is no skewness, then you can apply mean. If the data is having skewness, either left skew or right skew, in other terms we say negative skew or positive skew, in that case you can apply median, so that the data is adjusted to the middle. So we are importing simple imputer from scikit-learn.impute module, then importing numpy here, then creating a fresh data frame, and then creating object to the simple imputer, and these are the parameters. Missing values is equals to np.nan. They are identified with numpy.nan. And what is the strategy, means what is the method you are applying. So we replace with mean, and so df6 means this data frame dot I location, integer location, all rows, but the columns are 1 and 3, columns 1 and 3, applying the imputation, fitting this data to the imputer, fit and transform, then displaying the data frame. So row number 1 and column 1 and column 3. So column 1 means age and column 3 means experience. So these are numeric, so we don't have any missing values in the column age and also experience. It is replaced with the mean value. Then imputing with median. So everything is same, so same number of columns are used here, but my strategy is median. So imputing with median, then so we don't have any missing values, right? And next imputing with mode. So mode means frequent. So frequency of a particular value. So this is applied on only object type of column, object type of data. So we are looking at the data types of the columns. You see name is object type, and position is object type, and salary is object type. So if you have missing values in these three columns, then we can apply mode. So I'm getting the value count. So we have missing values in the position, and then getting the value count of positions. So the mode of this column is ML engineer. The frequency, the count is 3. Means if you have missing values in position, then you can replace with ML engineer. Then here we are doing the imputation. So imputer equals to simple imputer, and the missing values are identified with NaN. And what is our strategy? Strategy is most frequent, means mode. And all rows are selected, and columns, this is slicing by default starting from 0 up to 3, means not up to 3, up to 2 only. That means 0 1 2 first 3 columns. On first 3 columns, if you have object type of data, then we are doing the imputation with ML engineer. Now after doing the imputation, we don't have any missing values. Then imputing with constant. So based on the domain knowledge, if you feel that some particular value should be filled with some constant, in that case you can opt this method. So creating a data frame again, and then so if you have missing values, then the strategy is constant, and we are filling with the float value 10.0 on which columns? Column number 1 and column number 3. So we don't have any missing values. 1 and 3 we don't have missing values. You see it has been filled with 10.0. So these are the methods. I'll give you a short conclusion here. So no machine learning algorithms works with missing data. Then you have to find out the different ways of imputation. You can drop the missing values, or you can go for imputing, means replacing the missing values. So we have 3 approaches. You can impute with mean, you can impute with median, or you can impute with mode. So mode is applicable on object type of data, and mean and median are applicable on numerical data. So if the data is normally distributed, then you can apply mean, or if the data is abnormal, not normally distributed, it means if there is a skewness, then better to impute with median. So that's it. So feel free to ask any questions, and do like our videos, and do subscribe our videos, and so that you can get updated content.